Hi, my name is Arad Tahmasebifar, and this is my assignment 1 using Google Colab. I load fashion MNIST, explore the dataset, build a neural network called my network, train it using two compiler settings, and compare the results. So first I imported NumPy and Matplotlib and Keras, then loaded Fashion MNIST using Fashion MNIST load data. Fashion MNIST includes 60,000 training images and 10,000 test images. Each image is 28 by 28 grayscale, and there are 10 classes like t-shirt, trousers, sneaker, and ankle boot. Then I printed the dimensions of images, train labels, the test images, and test labels. And I printed the length of train labels and test labels. After that, I displayed some sample label values to show they are numbers from 0 to 9. So next, I displayed the digital content of train images 5, which is the 28 to 28 matrix of pixel values. Then I plotted the image using I'm show in gray scale. In yeah. So I checked the label, like this one, like where is it? Okay, here. So train labels 5, and it says it's 2, and the class name is pullover. Then I repeated the same steps for the test set. I showed the digital content of test images 500. I plotted test images 500. Then I printed test labels 500 and its meaning from the from class names. So as you can see here, it says like 2 and pullover. Okay. So next, before training, I normalized the images by dividing by 255, like train images norm, train images like 255.0, and test images norm, test images like 255.0. This converts pixel values from 0 to 255 into 0 to 1, which helps training be more stable and faster. So here now, as you can see, I built the sequential model called my network. The architecture is flatten input from 28 to 28 into 584, dense layer with 512 neurons, activation ReLU, and dense layer with 128 neurons, activation ReLU, and the output layer with 10 neurons, activation softmax. Then I ran my network summary to show the structure. So why softmax? So the reason we are using softmax in the last layer is because this is a multi-class classification problem with 10 possible classes. The model produces raw output called loggets. Softmax converts loggets into probabilities that are between 0 and 1, and sum to 1, then the predicted class is the one with the highest probability. So for question 17 and 18, as you can see, for option A, I compiled using optimizer Adam, loss, sparse categorical cross entropy, and matrix accuracy. Then I trained the model using epoch is 10 and validation split is 0.2. After training, I evaluated on the test data using evaluate. My option A result, as you can see here, is this one. The test accuracy is 0.8860 and the loss is 0.3437. So in the option B, I use optimizer RMS prop, loss categorical cross entropy, and matrix again accuracy. Because categorical cross entropy needs one hot labels, I converted labels using where is it? Using two categorical train labels 10 and label 10 and two categorical test labels 10. Then I created a new model, my network B, with the same architecture, train it for 10 epochs again, and evaluated it. My option B result, as you can see here, is the accuracy is 0.8739 and the loss is 0.4338. So when we are comparing both options, option A accuracy, as you see again, is 0.8860 and the option B is 8739. So in my notebook, option A performed better on the test set. So compared to classic MNIST digits and fashion MNIST is compared to classical MNIST digits, fashion MNIST is harder because many clothing items look similar in grayscale, like shirts versus to t-shirts or versus to polymers. That usually reduces accuracy compared to MNIST digits. For overfitting, I check whether training accuracy is much higher than validation accuracy and also whether test accuracy drops a lot. If the gap is small, overfitting is not served. So that's my assignment 1 walkthrough. I loaded the dataset, explored it, trained two models using option A and option B, evaluated them, and compared the results. So thank you so much and have a good day.